Okay, good morning to one and all. So, in the previous lecture, we have started the unit number 4, that is single phase transformer. In a single phase transformer, we have already discussed details related to working principle of single phase transformer. So, in the working principle, single phase transformer, or it may be transformer, it can be works on the principle of Faraday's law, works on the principle of mutual induction. So we have discussed regarding mutual induction, how the EMF it can be induced in the secondary winding, or we can call it as a secondary coil of the transformer. There is no electrical connection between primary winding and secondary winding, but there is a magnetic linking between primary and secondary. That means magnetic coupling between primary winding and secondary winding. Okay, when we are giving a supply to that of primary winding, then there is a EMF, it should be induced in the secondary winding. That means the flux produced by the primary winding due to current flowing from that primary winding, and some n number of turns. This current, due to that current, there is some flux it will be produces. This flux it will be traveled to the top secondary winding, and in the secondary winding, due to that flux, there should be some of the EMF it should be induces. Okay, so like that, there is a mutual induction between primary and secondary. Okay, so the transformer it should be works on the principle of mutual induction, and we have explained detail regarding mutual induction principle. And the magnitude of induced EMF, it is equals to, that is magnitude of induced EMF E, it is equals to, or it is directly proportional to d phi by dt. That means E is equals to n d phi by dt. We have already discussed this one also. Now, today we will discuss regarding most important one of the derivation, that is EMF equation of single phase transformer. That is EMF equation, it is very important as the exam point of view, as well as the problem which is based on the EMF equation. So the EMF equation, it is very important to understand at the exam point of view, as well as for solving a problem. Okay, so EMF equation similar to that of generator, we have derived one EMF equation. That means how much EMF it should be induces in case of transformer, or it may be in case of generator, how much EMF it should be generated in case of generator. We have derived equation EZ is equals to 5PNZ divided by 60A in case of generator, and we are deriving one equation in case of transformer. Okay, so transformer EMF equation, it is one of the important point. Okay, now see, do you know that the EMF of the transformer, it is depends upon flux produced by that winding, right? कशावरती डिपेंड आहे? EMF कधी जनरेट होतो किंवा कधी इंड्यूस होतो? It should be depends upon flux, right? बरोबर ना? Hello?
Yes, sir. Yes.
Okay, that means EMF induction, or it may be EMF, it should be depends upon the flux. So for deriving an EMF equation, we are considering a flux. And do you know that the flux produced in case of generator as well as in case of transformer, whether it is alternating quantity or it may be direct quantity, AC असतो का DC असतो? जनरेटर मध्ये आपण कन्सिडर केलं इंड्यूस्ड EMF, either it is alternating quantity or it may be direct quantity. AC का DC? In case of generator, we are using one of the commutator to convert it into DC. So EMF induced in case of generator, otherwise it is in the AC quantity, right? No, माहिती आहे ना? आपण simple loop generator consider करून how EMF it will be induces. We have plotted one graph related to that. That means one sine wave it can be obtained. So similar to that, in case of transformer, the flux produced due to current flowing from that field winding, it is an alternating quantity. So that for deriving an EMF equation, I am writing here one plotting a graph, that is the flux produced. So suppose I am writing a graph of flux phi with respect to that of time t, with respect to that time t. So it is equals to, it will be start from 0 and one cycle. We have considered a one cycle, that is the flux phi, it will be starting from 0 and one cycle it may be completed at 360 degree, having an magnitude, that means this is the value of flux, and having an magnitude, it is nothing but phi max. Okay, so see, consider the flux produced in the field winding, flux produced in the field winding due to current flowing from field winding, flux produced in the field winding due to current flowing in the field winding, it is equals to, so the magnitude of this flux, it is nothing but phi m, and one cycle we have represented, so that I am able to write one equation, phi is equals to phi m sin omega t. Okay, phi m sin omega t. So see here, time t, omega is nothing but at that means omega, it is nothing but an angular velocity. So we can written here equation phi is equals to phi m sin omega t. So time t to complete one cycle, suppose time t it can be taken to complete a one cycle. One cycle complete करण्यासाठी it will take some time t. Okay. See, for deriving an EMF equation, we have considered one of the flux, that is flux phi. It can be represented as a phi is equals to phi m, that is maximum value of flux, or we can write here phi max. Instead of writing m only, we are writing phi max sin omega t. Okay, sin omega t. Now, do you know that the equation, suppose consider here the primary winding of the transformer, it is some of the supply it can be provided, and when the supply it can be provided to that of primary winding, there is some current, it will be start flowing from primary winding. If the current it will be start flowing from primary winding, then some of the EMF it should be induces in the primary winding. So this induced EMF it will produces some of the flux. This flux it will be traveled to the top secondary winding, and again due to that flux there is some of the EMF it should be induces in the secondary winding, like that. Okay. So see where here we consider one value of flux, that is phi is equals to phi max sin omega t. So this is equation number 1. Okay. Now, do you know that the value of induced EMF E, it is directly proportional to rate of change of flux? We want to derive equation of induced EMF. So do you know that in the yesterday's lecture, we have already discussed in the working principle, the value of induced EMF, that is E. So the value of induced EMF, value of induced EMF E is directly proportional to d phi by dt according to Faraday's law of electromagnetics induction. Suppose consider there are n number of turns in case of primary winding. Primary winding la n number of turns ahead, or we can represent E is equals to, that is induced EMF E is equals to n d phi by dt, right? N d phi by dt. So this is one equation we got. So this is second equation. This one is the equation second. Now put the value of equation 1 in the equation second. Equation 1 ची value equation second मध्ये put केली, that means phi ची value आपण इथे put करतोय. So here equation becomes E is equals to n d by dt, put the value of phi in this equation second. So value of phi is nothing but phi max into sin omega t. Okay, phi max into sin omega t. Okay, what we have done here, we have represented the flux equation, that is phi is equals to phi max sin omega t, because here it is sine wave. So we are representing phi max sin omega t. Now do you know that the EMF induced in case of any winding, it is equals to, or it is depends upon rate of change of flux. So that we have represented E is directly proportional to d phi by dt. Instead of writing directly proportional, we have taken n number of turns it will be present on that winding. त्या winding ला n number of turns present आहेत असं आपण consider केलं. So that equation becomes E is equals to n d phi by dt. So this is equation second, and we have putted here the value of flux. Flux ची value काय केली? Put केली. Now induced EMF E, it is equals to induced EMF E, it is equals to n d phi by dt. So tell me the derivation of or derivative of phi max sin omega t. Phi max sin omega t चं derivation सांगा with respect to t. Anyone?
Phi max omega cos omega t.
Phi max into omega cos omega t, right? So see, phi max it is constant. We want to take derivative of sin omega t with respect to t. So derivative of sin, it is nothing but cos omega t. Again, by using chain rule, derivative of omega t with respect to t. So omega t with respect to t is a derivation. So t is a derivation. Derivative of t with respect to t, it is equals to 1. So only omega it will be remaining. So see the equation, that is induced EMF E, it is equals to n phi max, it is constant, omega into cos omega t. So I am writing here this equation, n omega phi max into cos omega t. Okay, all of you understood how this term it will become? कशी ही टर्म कशी आली लक्षात आले का सगळ्यांच्या?
Yes sir.
Okay, now see, this is the induced EMF E, it is equals to n omega phi max cos omega t, n omega phi max cos omega t. Now if I want to maximum value, okay, so that means I want to calculate the maximum value of induced EMF. That means I want to calculate the E max. Okay, so see, so when the E max value it will become, कधी E max value जास्त मिळेल मला? When when
T equal to 0.
T is equals to 0. So when we put the value of T is equals to 0, what is the value of cos 0?
1.
1. That means when I get the value of cos omega t, it is equals to 1, then my induced EMF value becomes maximum, right? बरोबर? ज्यावेळेस मला cos omega t ची value 1 मिळेल, at that situation I get the value of induced EMF, it is maximum. And when I get the cos omega t is equals to 1, when I put the value of t, it is equals to 0. ज्यावेळेस मी value of t, that is time, I will put the value of t, it is equals to 0, then I will get the value of EMF induced in case of transformer, it will be maximum. So here I am representing E max or E maximum, it is equals to n omega phi max into 1. Right? No, into 1. So that means I get the E maximum value. E max is equals to n omega into phi max. N omega into phi max. Okay. Now, generally the induced EMF in case of any machine, or generally the value, nameplate value on any machine, or it may be transformer, it is represented in the value of RMS value. Okay, so or it can be represented in the RMS form. RMS value च्या form मध्ये काय केलेलं असतं, represent केलेलं असतं. Now I want to convert this maximum value of induced EMF into RMS value. What is the formula for representing RMS value, or what is the formula? It will give the relation between maximum value and RMS value. Can anyone? Hello. Can anyone able to tell the formula which represent the relation between maximum value and RMS value? So that means I want to, RMS is nothing but root mean square value. I want to represent the RMS value. So can anyone able to tell the RMS value and maximum value relation?
Maximum divided by root 2.
Yes, yes.
Maximum divided by root 2.
Maximum
Divided by root 2.
maximum
RMS equals to maximum divided by root 2.
RMS is equals to, that means ERMS, it is equals to, suppose any RMS value, suppose I am writing VRMS. VRMS is equals to
Vmax divided by root 2.
okay, Vm, that is Vmax divided by root 2, right? Vm divided by root 2. Okay, so similarly ERMS is equals to Emax divided by root 2. So I want to represent it into ERMS. So here Emax च्या ठिकाणी मी RMS value put करतो. That means Emax is equals to Emax, that is E maximum, it is equals to root 2 into ERMS. बरोबर? Right? No. So instead of writing a maximum value, I am writing here RMS value. So RMS value, it is equals to root 2 into ERMS, that is root mean square value, is equals to n omega into phi max. Getting? काय केलंय लक्षात आलं का? I have put it here relation between maximum value and RMS value. Instead of representing a maximum value, I am representing it into RMS value. So maximum value of any quantity, it is equals to root 2 into RMS value, right? Barabar?
Yes, sir.
Okay. Now I want to calculate the ERMS value, that is induced EMF in the RMS value. So ERMS is equals to shift this root 2 into right hand side. So n omega phi max divided by root 2. N omega phi max divided by root 2. Okay. Now here we have represented the omega is nothing but angular value. So the formula for omega, how omega it can be represented? Omega kasa represent करतो आपण?
2 pi f.
2 pi f. Okay. So instead of writing omega, I am writing here 2 pi f. So it is equals to 2 pi f into phi max into n divided by root 2. Okay. Divided by root 2. So tell me the value of 2 pi divided by root 2.
4.4428.
Okay. ERMS is equals to 2 pi divided by root 2. It is nothing but 4.44 EF phi max into n. EF phi max into n volt. It is the EMF equation of a single phase transformer. It is the EMF equation of a single phase transformer. Okay. So all of you keep in mind the EMF equation of the single phase transformer, that is E is equals to 4.44 EF phi max into En. So here EF is nothing but frequency of supply voltage. EF is nothing but the frequency of supply voltage. Phi max is nothing but a maximum value of flux, and N is nothing but number of turns present in that winding, right? And the 4.44 it is equals to, or it is 4.44, it is a constant. 4.44 it is nothing but constant. So this 4.44 it will becomes by multiplying 1.11. दूसरा पण एक another one way is there, that means 1.11. 1.11 it is nothing but the form factor. So form factor, by multiplying form factor to the 4, we get the value of 4.44. So another way to derive this equation, it is nothing but by considering a quarter half time. For half quarter or it may be quarter half time साठी आपण काय करतो, एक मॅक्झिमम फ्लक्सची व्हॅल्यू कन्सिडर करतोय. Again from that way also we are able to derive the EMF equation. Okay, so this is the EMF equation, that is E is equals to 4.44 EF phi m into N, where EF is nothing but frequency of supply voltage, phi is nothing but maximum flux, phi is nothing but maximum flux, En is nothing but number of turns of that of winding. Okay, number of turns of that of winding. Now if we are representing this equation, in case of primary winding and secondary winding, suppose consider a primary winding having a number of turns, that is primary having number of turns, it is equals to N1, and induced EMF at the primary side, it is nothing but E1, and the secondary it is having a number of turns, it is equals to N2, and the EMF induced in the secondary winding, it is nothing but E2. So we are writing the EMF equation, that is E1 is equals to 4.44 EF phi m into N1, and similarly we are writing the secondary induced EMF, that is E2, it is equals to 4.44 EF phi m into N. So these are the induced EMF if the primary winding having an N1 number of turns, and if the secondary winding having an N2 number of turns, then the EMF equation becomes, E1 is equals to 4.44 EF, where EF is nothing but frequency, phi m it is nothing but maximum value of flux, and N1 is nothing but number of turns. Similarly, E2 is equals to 4.44 EF phi m into N2. Again, this relation or this equation, it can be represented in the another form. Do you know that what is the relation between maximum value of flux and flux density? काय relation आहे maximum value of flux आणि flux density चा? हॅलो, हाँ, फ्लक्स डेन्सिटी कशी रिप्रेझेंट करतो आपण? हॅलो, फ्लक्स डेन्सिटीचं नोटेशन, how it can be denoted? B, right? That means B. What is the relation between phi and B?
Phi upon A.
Okay, that means B is equals to phi upon A, na? बरोबर ना? हाँ, so that means we are writing Bm, that is maximum value of flux density, it is equals to maximum value of flux divided by A. Okay, A is nothing but cross sectional area of that core. Okay, so see, that means the maximum value of phi, that is phi max, is equals to Bm into A. So instead of writing phi m, we are able to write the Bm into A also. बरोबर ना? हे लिहू शकतो ना मी? Hello?
Yes, sir. Yes, sir.
That means again this equation becomes, that means we are rewriting this equation. E1 is equals to 4.44 EF Bm into A into N1. Similarly for secondary winding. So suppose we are representing, this is equation A. As a पहले equation अपन A represent करू. This one is the B equation. Okay. So all of you write this EMF equation of single phase transformer. Or झालं?
Yes, sir.
Okay, I will rub this side. So this is very easy. That means EMF equation. Definitely the question it may be asked, derive an EMF equation of the single phase transformer. So it's very easy, and there is a that means no single mark it will be lost, because just it is mathematical, or it may be just it is stepwise. So each and every step there will be a mark. Okay, once we have derived a EMF equation, that is E is equals to 4.44 E of phi m into A, E of phi m into N. So this is the EMF equation of the single phase transformer, and this is useful while solving a problem also. Again, I have given that equation, instead of writing phi m, I am writing Bm into A also, because relation between phi m and B, that is flux density, and the maximum value of flux, that is Bm is equals to phi m into A, or phi m is equals to Bm into E. Sorry, Bm is equals to phi m divided by A, and phi m is equals to Bm into A. Okay, so see, this is the EMF equation of the single phase transformer. Single phase transformer is EMF equation. Now, from this single phase transformer EMF equation, we will deriving the voltage equation, or it may be transformation equation or transformation ratio. Okay, that means from EMF equation of the single phase transformer, we are able to derive the voltage equation or the voltage transformation ratio, or we can generally representing the transformation ratio. See, do you know that this equation A and equation B, that is E, it is equals to, or E1 it is equals to 4.44 into EF, that is frequency, into maximum value of flux into N1 number of turns. So this is the equation A. And similarly, in the secondary winding, the induced EMF E2, it is equals to 4.44 into EF, 4.44 into EF, into maximum value of flux into value of number of turns in the secondary winding. So this is the equation B. Okay. Now we want to derive the transformation ratio, or it may be voltage ratio. Voltage ratio derive करायचं किंवा transformation ratio we want to derive. Now take the ratio of these two equation. That means take the ratio of second equation divided by first equation, or second equation, that is equation B divided by equation A. A आणि B equation चा काय करायचा, रेशो घ्यायचा. So do you know that E2 divided by E1 left hand side, it is equals to 4.44 F phi m into N2 divided by 4.44 F into phi m into N1. So this 4.44 F phi m get cancelled, right? बरोबर ना? Hello. So
Yes,
these terms remains constant because these two terms are same. So sorry, these are the cancel. So equation becomes E2 divided by E1. It is equals to N2 divided by N1. E2 divided by E1, it is equals to N2 divided by N1. So this is equals to K. Okay. See, second equation divided by first equation, that means secondary induced EMF. We are taking the ratio of secondary induced EMF divided by primary induced EMF, that is E2 divided by E1. It is equals to 4.44 F phi m into N2 divided by 4.44 F phi m into N1. So 4.44 F phi m, it get cancelled. So equation becomes E2 divided by E1. It is equals to N2 divided by E1. N2 divided by N1. It is equals to K. And here K is nothing but the voltage, or K it is called as voltage transformation ratio. K it is called as voltage transformation ratio, right? K it is called as a voltage transformation ratio. It is nothing but K. Voltage transformation ratio, it is equals to K. Okay. Now, so all of you keep in mind that is secondary EMF divided by primary EMF. It is equals to secondary number of turns divided by primary number of turns. If in case of ideal transformer, so that means I am expanding this ratio. So if in case of ideal transformer, so do you know that the ideal transformer, there were no losses, right? Barabar na? Ideal condition we are considering, that means there were no losses. So that means supply voltage at the primary side, it is equals to induced EMF at the primary side, because we are not considering the losses or voltage drop. So supply voltage V1, it is equals to induced EMF E1. Similarly, induced EMF E2, it is equals to secondary voltage V2, right? If the ideal transformer is there. So see, ideal transformer is there, that means V1 is equals to E1, V1 it is equals to E1, and V2 it is equals to E2. Okay, so put this value also, this value पण put करून घेऊया आपण. Then we will get the transformation ratio. K is equals to see V1 divided by V2. So that means our previous equation, that is E2 divided by E1. Again E2 and E1, that is E2 is equals to V2 and E1 is equals to V1. So that equation becomes V2 divided by V1. It is equals to N2 divided by N1. It is equals to K. Right? Now, again the transformer, it is ideal we are considering. So we are considering the transformer, it is nothing but ideal transformer. So in case of ideal transformer, do you know that the power at the input side, it is equals to power at output side, right? There is no losses. That means whether there is a power difference in their primary and secondary,
No, sir.
or input power and output power,
No, sir.
difference असेल का काय त्याच्यामध्ये?
No, sir.
No, that means power remains same at the primary side or at the input side and output side. So according to this, that is power P1, it is equals to P2. Primary power, it is nothing but secondary power. So do you know that the primary power formula, primary power, it is nothing but V1 into I1, and the secondary power, it is nothing but V2 into I2, right? In case of, we are considering in case of ideal, we are considering the ideal transformer. So in case of ideal transformer, V1 is equals to I1 and V2 it is equals to I2. So according to this, we will get another one ratio, that is V2 divided by V1. I am shifting this V1 on the right hand side. I am shifting this I2 in the left hand side. Okay. See, that is equation becomes V2 divided by V1. It is equals to I1 divided by I2. Okay. So see, again the transformation ratio, it is nothing but we are writing transformation ratio E2 divided by E1. It is equals to V2 divided by V1. It is equals to N2 divided by N1. It is equals to I1 divided by I2. All of you keep in mind the change. All are secondary voltage, secondary number of turns on the denominator, on the numerator, but current, that is primary current, on the numerator side. So there is a reverse in the relation. So I1 divided by I2, it is equals to K. This is the transformation ratio of a single phase transformer. This one is the transformation ratio, that is K. and this K, it is very important while solving a problem, or by drawing a equivalent circuit diagram, also by drawing a shifting one value to the other side. That means by referred value, by referring value to the any one of the side, it is very useful. So this is the transformation ratio of a single phase transformer. A single phase transformer transformation ratio. Okay, getting लक्षात आलं? लिहिलं का सगळ्यांनी? All of you right? Or
Yes, sir.